touch on the ICMTS here, the high pressure valve that would be running from that 0 to 10 volt signal off either the pack controller or the EKC. Here we do need to, we get some different terminology here with the ICMTS. It comes from our industrial refrigeration group, but in that group, a lot of the terminology on these valves, you have the top part, it's called, which is, I kind of associate to being the actuator, but they call it the top part of the valve. That does need to be removed in an ICMTS when it's being installed in the system. So we really do just want the valve body before it's welded into the rack. As you can see, kind of this third depiction on the right side of the 3 there at the bottom.
Okay, yeah. So you definitely take out the valve on the ICMTS valve.
Yep. It really has to be mounted in an upright position. Even horizontal is not okay with this valve, as you can see. Part of that goes back to the actuator. It is a larger, the iCAD is a larger actuator that has a good bit of weight to it if anybody's ever picked one up. So it's only using 3 small set screws to hold it in place on the valve body. So even a horizontal position there, you're really running the risk of that actuator coming loose over time and not being able to drive the valve open and close. So we do want to see that mounted in an upright position on the rack.
And it has to be level. I've seen some on angles before where a lot of like condensate got inside and start to rust them up. So insulation is important as well on those.
Yep. Yeah, I can't say I've seen a rack where it's not insulated around the valve body. So yeah, I agree with you on that part. Yep. For troubleshooting it, like we've been talking about these last few slides, main switch is again something that we start with. It's an easy check. It's something that we can look at right away on a new install. Sometimes guys just aren't familiar with the fact that they need to do that. And then from there, we'd move to that 0 to 10 volt signal coming out of whichever controller we're using to go to the iCAD. So we want to make sure, A, that we're getting some type of voltage, and then B, we would move on to, again, those parameters in the EKC if that's where we're looking, or service tool if it's the pack controller. But we can compare what opening degree the controller thinks the valve is at versus what voltage signal is going to the valve, and then move on there to maybe manually opening the valve to see if it's moving at all. But if we think the controller is shooting for a 50% opening degree at some point in time, 60, 70%, whatever it might be, when we check that parameter for opening degree, we should be able to take a meter, measure the voltage at the output of that controller or going into the iCAD, and we should be able to see a voltage that matches up with that, knowing it's a 0 to 10 range. So 50% open being 5 volts, 60% open, 6 volts, etc.
Have you ever seen it where it's like 80% on the valve itself, but you're only getting 5 volts out of the controller? Like it's 80% open, 5%, or any vice versa like that? Maybe it's supposed to.
I can't see. I've run across that scenario before. Usually that's something that always matches up between the controller and the voltage signal.
And so what kind of things can you see with that? So, because I've seen it before where people are looking at the main controller on the rack, looking at that pressure, and it's, or do you get that feedback signal going from the controller from the U, and it says, oh, it's supposed to be 80% open, but actually when they went on it, it's not 80% open. Is there any things that you've heard for troubleshooting to help people out on what could happen or what you've seen as issues out there?
Yep. I'm going to guess that most people don't even have that feedback available to them that we showed earlier. That was a newer function that we added into the iCAD. So especially on older installs, that's probably not even there as an option. And when we do have it, it is just a feedback of that signal. There's no infrared technology or anything along those lines happening within the valve to actually confirm the opening degree. So normally either we're looking at something where there's redundant pressure transducers or temp sensors, and if somebody's looking at the one that's tied back into a supervisory controller, then we need to make sure they're also looking at that same reading in the EKC, because there's obviously the chance that they're different, and so what they think they're seeing isn't what is actually going on inside the controller. But then otherwise, it's really getting back into the EKC parameters and looking at these U settings to either check that opening degree of the receiver valve on U24, or the high pressure valve for the ICMTS would be U04. we go to that setting in the EKC, and that should give us an opening degree percentage for the ICMTS in particular, that we could then turn around and look at the top of the ICAD and see if it's the same opening degree there. That should match.
Have you ever seen it when it's different?
We've had one or two instances over the years, I think, and it ended up being that the ICAD was bad from what I recall.
Okay.
So the voltage seemed okay. The opening degree in the EKC was at a reasonable level based on what the set point was and the pressure was of where we thought the percentage should be. The ICAD was different. And I think we ended up replacing the ICAD once or twice, and that resolved that.
Yeah, and that's rare occurrences.
Yeah, exactly. Once or twice over the course of however many years that thing's been on the market, which has been a long time. So
not saying it can't happen, but it's very unlikely. And I've seen that with other valves as well. There's certain things that can happen the odd time, but you don't see it all the time happening.
That's just where good troubleshooting comes into play. We don't want to jump to that conclusion. We want to rule out all these other things we're talking about first, these checks, to kind of narrow in on here's where the component or the feature, whatever it is, try to narrow it down on one item and then make a smart decision to say, okay, we're not what we expected, but let's go ahead and try to replace that and see if it helps or not.
The last thing you want to do is be replacing parts. Most of the time, and we'll get into more of it, wiring on at the beginning, and this is usually during commissioning. A lot of the stuff we're talking about, you'll see at commissioning. Wiring, that means switch on, parameter set points, which maybe sometimes you get the system up and running and they're not perfect, but those are the things that you want to look at before you're okay, let's change the controller, let's change the ICAD, let's change the valve itself.
Yep. And then if we've got an operational system, we talked about some things like the magnetic tool again that I've got here. So yeah, that can be used to manually drive the valve if we feel like that's something that we need to do as part of the troubleshooting. The valve can be disassembled, and then we have replacement components. So this wouldn't be, you'd have to, especially on the high pressure side where it's welding, anytime you're saying you got to cut a valve out, that's tough to hear. So luckily with the ICMTS, that's not the case most of the time. The valve body can stay in place and the other components changed out. But then we do also get on the ICAD itself, so not in the EKC, but on the ICAD, because we have that small display, you do get some alarm that can pop up on the ICAD. And so it's small, I know, but on the slide in the bottom right corner, there's a cutout from the user manual. So you can refer back to that if you need to see some of these alarms. But you can get an alarm code there that if you're having problems, you can check and it would point you in the direction of what type of alarm it is. Typically some sort of signal that we're not getting that we think we should. And so, yeah, you can use this as a troubleshooting guide as well.
Yeah, and it's important to take those. You're not going to remember all these, so if you do have, say, an A3, go and look up what A3 is, alarm on, and then you got to check those set points, in there, not active, when active. And how do you, for example, that's a good one, the analog input error A3. It says on the side, greater than 22 milliamps, 12 volts. Where would you check that? What would be the...
So that would be your 0 to 10, or ICAD does have the option instead of a 0 to 10 signal, it can run off a 4 to 20 if we have maybe something else driving it other than the EKC. But that's where it also becomes important when you look at the user guide that I'll bring back in here to understand all your settings. And I think the OEMs do a good job of knowing what settings should go in for these. I know a lot of them have documented what numbers they want for their systems. So it's always something you can check with them. But there's settings that say, are we expecting on the ICAD side a 0 to 10 or a 4 to 20? So if you're using an EKC 326, for example, where the 0 to 10 is the only option, but the ICAD is set to expect a 4 to 20 milliamp signal, then that's obviously not matching up. And that's where we need to focus on changing that setting in the ICAD so that they do. Things like that, when you really look at the EKC and on the OEM side, understand what a lot of these settings should be. Because for us, we're not necessarily going to know. Yes, we know by definition what the control or what the parameters are intended to do. But when somebody might ask, what setting should this be at? I can give you a range that makes sense. But a lot of times we'd say, you want to talk to the OEM it's their rack, it's their design, and understand exactly what number they want now that you understand what that setting means and what's intended to do.
Yeah, but I've had situations where the technicians will call me up and say they can't get the information from from the manufacturer. So sometimes it's you need to talk with different people from that manufacturer to try to get the help. And at the
Yep.
end of the day, you're going to need the model number of the rack, serial number of the rack, the location of that rack, and find someone who can get that exact documentation. Usually, this should all be shipped with the package of that rack manual, but I've manufacturer rack, but I've seen it where technicians told me that they couldn't get the information from the manufacturer themselves. So just be aware of that. That's why it's so important to understand that whole system, how it's running. So when you are in a situation like this, you can get it through until you got a controls guy or the guy who set it up back there.
If you're not sure if the valve's the issue or the controller is the issue, what you can do is take the 8-pin male connector off, and you can check from F and D. So F is your green, that's your 0 to 10 volt input, and green is your ground. This is coming from your main controller that is opening and closing the valve. If you're not getting a signal from there, maybe it's something from the controller side. If you are getting a signal and the valve is not moving, well, maybe now you need to manually open, manually close, check if there's dirt inside there. So this is one extra check before you deem the valve a failed valve. I would recommend pumping down the system if you can before doing this, because when you pull off this, the valve is going to stay where it's at